Okay, our first topic for this term, we're going to be looking at some probability distributions. So what is a probability distribution? Well, it's a probability distribution basically assigns numerical values to the outcomes in a particular sample space. So those outcomes might be numeric. So the roll of a dice, for example, your elements, you could have a 1, a 2, a 3, a 4, a 5 or a 6. Or they might be categorical. Example I've put there are blood types. So A plus, B minus. Now, just to define the term here, a random variable. So we're interested in random variables. Basically, it's a type of function. And that function is the probability of the event occurring. Some notation, random variables, we represent them with an uppercase letter. And the values, the corresponding lowercase letter. And you'll notice I'll often use capital X for the random variable and little x for the value. Now, random variables are continuous if the range of answers forms an infinite set of real numbers. In other words, it's an interval, as opposed to discrete random variables, and that's if your range is countable. So it consists of individual values. So a continuous range might be all the numbers from 1 to 10, as opposed to a discrete one would be just the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Interestingly, it is possible for a discrete sample space to have an infinite number of countable things. So for instance, the example I put there, if X was representing the number of times we have to roll a dice before a 6 occurs. I mean, theoretically, you could roll it an infinite number of times before a 6 occurs. Okay, let's have a look at an example. We're going to toss a coin 3 times. So my random variable X, the function, we're going to define it as the number of heads thrown. The sample space would be all of these outcomes. So head, 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 tail, and so on and so on. Now the sample space of my random variable though would be the numbers 3, 2, 2, 2, 1, 1, 1, and 0. Because they're the number of heads I could possibly throw in each of those situations in the coin toss. Now if I put that into a table, so little x is the number of times that it occurs. And so the probability that x equals little x, so 1/8, 3/8, 3/8, and 1/8. So that's our probability distribution. If I was to plot it, and you can see on the x-axis I've placed 0, 1, 2 and 3, and then I've plotted the relevant probabilities. And that's a graph of our probability distribution. So some properties here. Well, we know we always have to end up with a positive amount, because we're talking about a probability here, which also means the sum of all those probabilities must add up to be 1. Just a note here, if the probability is the same for every single outcome, then we say our distribution is uniform. Okay, so that's just a bit of a start on our look at distributions.